Hello, this is Dr. Rachel Winston, and I would like to welcome you to this edition of the Mathematics video series on prime numbers and divisibility. Numbers and their meanings have been important since the dawn of civilization. Numbers describe and govern the universe. They determine quantity, magnitude, shape, and symmetry. Certain numbers, like 7, are considered special, mystical, and even magical. The importance of the number 12 dates back to the 12 tribes of Israel and the 12 disciples of Jesus. 12 is also special because it is divisible by 1, 2, 3, 4, 6, and 12. Another grand number is 360, the number of degrees in a circle, because it is divisible by more numbers than any other number between 1 and 500. The first recording of natural numbers dates back to stone carvings from the Egyptians and Babylonians. However, the systematic study of numbers is considered to begin with Pythagoras and Archimedes. The foundation of number theory lies in understanding prime and composite numbers. Prime numbers are natural numbers that are divisible by only 1 and itself, while composite numbers are natural numbers that are not prime, or those with at least one positive divisor other than 1 in itself. Recall that the natural or counting numbers begin with 1. We say that the natural numbers come from the set of all x such that x is an element of the numbers 1, 2, 3, and so on to infinity. We will walk through these. First, 1 is not prime. Next, the first natural number that is prime is 2, and 2 is the only even prime number. 3 is only divisible by 1 in itself, so 3 is prime. 4 is a composite number because its factors are 1, 2, and 4. 5 is prime because its only factors are 1 and 5. 6 is a composite number because the factors of 6 are 1, 2, 3, and 6. 7 is prime because 7 can only be broken down into the factors 1 and 7. 8, 9, and 10 are composite. The next prime number is 11. 12 is a composite number, but 13 cannot be broken down further, so it is a prime number. Long ago, the Greek mathematician Eratosthenes devised a technique called the sieve of Eratosthenes. He created a grid of 100 numbers and showed how to sift through the numbers, eliminate the composite numbers, and leave only the prime numbers. Let's start with 1, but 1 is not prime. 1 is not a composite number either. Put an X on the number 1. The first natural number that is prime is 2. Recall that 2 is the only even prime number. Put a circle around 2. Since all of the multiples of 2 are composite numbers, shade those numbers. Now, 3 can only be broken down into the factors 1 and 3. Thus, 3 is prime. Put a circle around 3, but all of the other multiples of 3 are composite numbers, so include those numbers in the shaded region. 5 is prime. However, the multiples of 5 are composite numbers, so we circle the 5 and shade all of the multiples of 5. 7 is prime, so it is circled, but the multiples of 7 are composite numbers. That means that 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 91, and 98 are composite, and they must be in the shaded region. Check the numbers left over that are not shaded. These are all prime numbers. There are actually an infinite number of primes. This was proved by Euclid more than 2,000 years ago. A 17th century French monk named Marin Mersenne proved that any number in the form 2 to a prime number minus 1 is prime. Thus, since there are an infinite number of prime numbers, then there should also be an infinite number of Mersenne primes. But each one must be painstakingly proven to be prime rather than determined by assumption. The first 4 prime numbers are 2, 3, 5, and 7. So the first 4 Mersenne prime numbers are 2 to the second minus 1, or 3, 2 to the third minus 1, or 7, 2 to the fifth minus 1, or 31, and 2 to the seventh minus 1, or 127. Although there is a contest called the Great Internet Mersenne Prime Search, Any new ones found are determined digitally. Now let's talk about divisibility. A number is divisible by another number if the number can be divided in with no remainder. In other words, when you divide a number by another number, the result is a natural number. Remember that you can never divide by 0. However, you can divide a number by 1. Any number divided by 1 is itself. So 5 divided by 1 is 5. 143 divided by 1 is 143. If a number divides into another number, it is only divisible if it divides evenly with no remainder. Here are some important divisibility rules. A number is divisible by 2 if the last digit is 0, 2, 4, 6, or 8. For example, 46 is divisible by 2, but 47 is not. A number is divisible by 3 if the sum of the digits is divisible by 3. For example, the sum of the digits of the number 633 is 12. And since 12 is divisible by 3, then 123 is divisible by 3. However, the sum of the digits of 125 is 8, and 8 is not divisible by 3. So 125 is not divisible by 3. A number is divisible by 4 if the last two digits are divisible by 4. For example, in the number 712, 12 is divisible by 4. So 4 divides into 712. But in the number 802, the last two digits are 02, and 4 does not divide into 2. A number is divisible by 5 if the last digit is either 0 or 5. This means that 80 and 85 are divisible by 5. But 81 and 86 are not, because they do not end in 0 or 5. A number is divisible by 6 if the number follows the rules for divisibility for both 2 and 3, since 6 is 2 times 3. For example, 5,412 is divisible by 2 because it ends in 0, 2, 4, 6, or 8. And 5,412 is divisible by 3 because the sum of the digits is 12, and 3 divides into 12 evenly. So 5,412 is divisible by 6. A number is divisible by 7 if 7 divides unevenly. There is no quicker way. You just have to do the long division, dividing by 7. So divide it out and check. A number is divisible by 8 if the last three digits are divisible by 8. This means that 9,016 is divisible by 8 because the last three digits are 16, and 16 is divisible by 8. A number is divisible by 9 if the sum of the digits is divisible by 9. For example, the digits of 95,418 add to 27, and since 27 is divisible by 9, 9,418 is divisible by 9. A number is divisible by 10 if the last digit ends in 0. So 40, 450, 5,230 are all divisible by 10. The last one we will do is the divisibility rule for 11. This is really cool and typically not in a textbook. Find the sum of every second digit and subtract out the sum of the rest of the digits. If the result is 0 or 11, then the number is divisible by 11. For example, in the number 9,339, 3 plus 9 minus 9 plus 3 equals 12 minus 12, which is 0. Here is a chart of these rules all together. It's a nice way to visualize all of the divisibility rules. You will save a ton of time if you remember these rules. These are helpful rules for all of mathematics as you progress through algebra and higher levels. If you have these rules down, you will be able to do computations much more quickly. Numbers obey powerful laws that help us understand the universe. The beauty of mathematics lies in its structure. Understanding prime numbers and divisibility is a key to unlock mathematics. In the words of the great mathematician Carl Friedrich Gauss, it is not knowledge, but the act of learning, not possession, but the act of getting there, which grants the greatest enjoyment. This is Dr. Rachel Winston signing out and hoping you find this journey through number theory fascinating.